17.4 is how do we multiply radicals. So kind of a quick review. How did we do all this addition and subtraction on the back? They had to be like radicals, so see how these both had root 3's? Since they both had root 3's, we could just add the coefficients 7 plus 2 and get 9. And then these both had cube root of 5x's, so we could just do the math 4 minus 8 cube root of 5x. You should have it is what we started on Wednesday, okay? So what we had to do is we had to break them down and make them look alike. So like these both had root 5, so we could just do the math of 3/4 minus 1/3, and so forth, all right? How we do multiplication is in order to multiply, they don't have to be like radicals, okay? They have to be like roots. So like you only have a square root times a square root, and so forth, can you do? So what we're going to do is we're going to FOIL these bad boys just like we normally would and see what we get. So it should be on the back. Yeah, right back there. Okay. So FOIL, the F stands for the first terms. So we're going to take 2 times 2 root of 5. Notice he has no root, so he's just going to multiply by the outside number. So the outside numbers multiply with each other, and then the inside numbers are going to multiply with each other, okay? So 2 times 2 root of 5 will be 4 root of 5. And then O in FOIL stands for outer. So we're going to take 2 times negative 3 and get negative 6. Is that okay so far? Then the I stands for inner, so we're going to do the inside. And again, whatever's on the outside, so this 5 and this 2 are on the outside, they're going to be multiplied. So negative 5 times 2 is a negative 10. And then since they're both square roots, we can do the math underneath the root. So 10 times 5 is the square root of 50. And then last but not least, L stands for last. So negative times a negative is going to give us a positive. This 3 on the outside is going to multiply by that 5 on the outside and get us 15 root 10. Does that look okay so far? Alright, so your first initial thing is just to FOIL like normal. So if they are just a constant times a constant, you multiply like normal. A constant times a radical, the constant's out in front, okay? But if you have a radical times a radical, you'll do the math underneath. Once you get this, we basically turned it into what we saw on Wednesday. We're going to go see what we can break down to see if we have any like radicals, okay? Can 5 break down any further? No, so he's going to stay that way. Can 50 break down further? Yeah. How can 50 break down?
25.
25 and 2? And then how does 25 break down?
5 and 5.
5 and 5. Okay. And then what about 10? Can 10 break down? He break down to a 2 and a 5, but does that help us? No, because a square root, you need a pair in order to come out, and there's not a pair there, okay? So we're going to go back to this one that we broke out. The 5's going to come out, but when he comes out, who does he have to multiply by? That 10 that's out in front, right? Okay? So the 4 root 5 is going to stay as is. The minus 6 is going to stay as is, but that 5 will come and multiply with that negative 10, and the root 2 will be what's left, and then 15 root 10 will stay as is, okay? So 4 root 5, nothing we can do with him. Negative 6, nothing we can do with him. And this will become negative 50, because the 5 times the 10 that was already out there. And then who's the guy that stays on the inside? The 2. And then back here, guys, 15 root 10 is just going to stay 15 root 10, because there was no pairs. At this point, do we have any like radicals? No. We have the square root of 5, which is not the same as the square root of 2 or the square root of 10. As ugly as it is, that's actually your final answer. And you do have to do this step no matter what. So even though it didn't make a like radical, you can't leave it with the root 50 because technically it's not completely simplified. It's almost like if you had a fraction 10 over 20. Like my math lab would not accept 10 over 20. They'd want you to reduce it to 1/2. That's kind of the same idea. They wouldn't accept root 50 because it's not completely simplified. But sometimes you are going to be able to combine like terms. I think on B, not quite yet, but let's go ahead and see what happens on B. We're going to FOIL just like normal, okay? So 1 times 2 gets us 2. 1 times the root 10 is just a root 10. 5 root 6 times 2, this 2 is only going to multiply by that 5, okay? So it's going to be 10 root 6. And then this 5 root 6 times this root 10, the 5 is going to stay on the outside, but since they're both square roots, we can do the math 6 times 10, or 60, on the inside. Is that okay? So 1 times 2 is 2. 1 times root 10 is just a root 10. 5 root 6 times 2 is just a 10 root 6. And then 5 root 6 times root 10 is 60. And again, guys, once we do that, we're just going to go to each term to see what we can break down, all right? So 2, he's just going to be a 2. 10 is a 2 and 5, but that doesn't help us, okay? So if you can look at that and know that there's not a pair, you don't even have to write that, okay? 6, what is he? A 2 and a 3. So again, that doesn't help us because we don't have a pair of anything. But 60, we're going to be able to simplify him. What are any two numbers that multiply to be 60? 6 and 10. So 6 breaks down to 2 and 3, and 10 breaks down to 2 and 5. Is that all right? So what pair do we find on the inside of 60? A pair of what? 2's. All right, so we're going to have these 2's come out. But when they come out, they're going to multiply by that 5 that's already there. Who's going to stay in? The 3 and the 5, and they'll just multiply to be the remainder on the inside. Okay? So let's go ahead and rewrite all these terms. 2 didn't change, so he's just going to be a 2. Root 10 didn't break down anymore, so he's just a root 10. 6 didn't break down anymore, so that's just a 10 root 6. And then last thing, the 2 came out, so 2 times 5 is 10. And then what are we going to have on the inside? 3 times 5 or 15. Does that look right? You go look and see if we have any like radicals. We don't. We have a root 10, a root 6, and a root 15. So that's our final answer. We're just working on the very last 4 problems from Wednesday's note, 17.4. Okay, so both of these you'll see when we start out with radicals. So if you look at A and B, the starting problems, they don't have any radicals that look alike. So a lot of times when you multiply, they're not going to have any radicals that combine. But when you look at C and D, guys, start noticing stuff. Do you notice on C and D how we have like root X's and root 2's in both? So things are going to kind of start combining a little bit better. All right, so help me out here. We're going to multiply by doing FOIL again, all right? So root x times root x, well, what's x times x? X squared. X squared. And it's all under the radical, right? And then we're going to have root x times negative 3 root 2. The 3 is on the outside, so he's going to stay the outside. And then the x and the 2 are on the inside, so that's just going to be 2x, like that. Then we're going to have positive 3 root 2 times root x. Again, the 3 is going to stay on the outside. And the 2 and the x will multiply on the inside to give you a 2x. And then last but not least, let's just be careful with our sign. Positive times a negative will give us a negative. The 3 times 3 on the outside will give us a 9. And then root 2 times root 2 will give us a 4 on the inside. Does that look okay? Or any questions where anything came from? So everything had like a root, so we did multiplication under the root. So the x times x gave us x squared. The 3 stayed on the outside as we multiplied the 2 things under the root, 2 and x. And then we had our inner stuff, 3 root 2 times x. Again, the 3 stayed on the outside and the 2 and the x multiplied. And then our last, 3 times 3 were both on the outside and 2 and 2's were both on the inside. Okay, so we can break it down because what's the square root of x squared? What was x squared? It was x times x. So guess what we have a pair of? X's, right? And then 2x and 2x won't break down any, but what do you notice about them? We have a negative version and a positive version. What's going to happen when we try to combine them? What'd you say? They're going to cancel out, right? So we're going to cancel these out. And then how does 4 break down? 2 and 2. So a pair of 2's is going to come out, and when they come out, they're going to multiply to be with the 9 there, okay? So the square root of x squared is going to have an x pop out. The 2 inner terms were opposite, so they canceled. And then here, the square root of 4 was a perfect square, so we'll have no one left in the house. And then 2 times 9 gives us 18. Look at that. Look how much more simplified that one is compared to the other 2 that we did. Guys, I know it looks weird, but it's kind of that difference of squares. Remember, what's the square root of x? The square root of x, what's the square root of 18? If you broke that down, it's that, see how they have opposite signs, but they're the same terms? That's just a difference of squares formula for something that's not a perfect square, like 18, which is kind of interesting. All right, last one, really it's not a whole lot different than the one we just did. It's just rewritten, not like the original. What does anything squared mean? It's it times itself, right? So this is the square root of x plus 2 times the square root of x plus 2. So when you have it squared, you don't just square the square root and square the 2. You have to square the whole thing. This one's really nice because things clean up or at least combine, okay? So this one's kind of like your normal FOIL, okay? So let's start by doing root x times root x. Well, that will give us the square root of x squared. Root x times 2, the 2 will stay on the outside and the root x will kind of just tag behind it. And then we have that again, right? So 2 times root x will give us another 2 times root x. And then 2 times 2 will give us 4. Does everybody see where everything came from? So root x times root x is root x squared. Root x times 2 is 2 root x. But then we do it again. 2 times root x is 2 root x. And 2 plus 2 is 4.
Okay, how is the middle one not 2x again? If that makes sense what I'm asking.
Like in the inside?
Yeah.
Because the 2 is not under the root, so he won't go under the root. So I kind of call him the outside, so if it's just a constant, he's always just on the outside. Like you would take 2 times x, right? At this point, do you guys agree that x squared would break down to x and x again? So that would be an x. And then these will not cancel, but they are like terms. They both have root x's, right? So you have 2 in this hand and 2 in this hand. How many total do you have? What's 2 plus 2?
X squared.
4 root x.
4 root x.
Remember, whenever you add, you don't change it at all, right? It's like you have 2 x-rays here and 2 x-rays here, you have 4 x-rays, okay? And then plus 4, and we're done.